That is true. That is
It was fighting me earlier today too. All right, let me try this.
I'm so sad.
Thank you. Well, this morning the computer decided that it had two monitors, and so it wouldn't. There we go. It wouldn't show me what was on my monitor. It thought it was plugged into a laptop also, which there's no laptop. So that took me about 10 minutes to figure out how to get it to stop mirroring. Just computers. All right, so the questions I got, one was about Lewis structures, Vesper, resonance, and polarity. And the other one was about some mole fraction stuff. And then I'll open it up to whatever else anyone has any thoughts about. All right. No problem. Alright, so for the following, draw a Lewis dot structure. If it has resonance forms, draw them. It may not have any resonance forms. And then determine if the overall molecule is polar. Alright, so let's do that one. And maybe I'm going to save that one and use SF4 for something later. I might use it twice. Maybe. All right, for the first one, CHCl3, which atom do I put in the center of the molecule? Carbon. Why would I choose carbon of those three? Least electronegative. Excellent. All right, carbon brings how many valence electrons? 4. Hydrogen brings 1. And then chlorine each brings 7. So that's 28 plus 4. No, that's not right. 21. 21 plus 5. Okay, 26. Good. 26 electrons. At the end of the day, my math skills are rapidly declining. All right, do I want to put any more electrons around the carbon? No, the carbon's, how about more electrons around the hydrogen? No, all right, it's the only place left to put them. Do I do anything else to this molecule to finish drawing it? Or is it done? Done, all right. Does it have a resonance form? Is there any way I can move those electrons around? No, right, because carbon can't have any more double bonds because then it'd be too many. Hydrogen can't have any double bonds, so no resonance forms. Is this molecule polar? Yes. Overall, the molecule is polar. All right, let's talk through how we know that. All right, I have chlorine and carbon. Which of those is more electronegative? So which way are the electrons going? To the chlorine, okay. That's true for all of them, good. All right, let's compare the carbon and the hydrogen. Which one's more electronegative? Carbon, so where are the electrons going? They're going in. Do they cancel each other out? Polar. What Vesper shape does this have? Tetrahedral. Both, in this case. Because there are no lone pairs. It's the same. All right, BF3, one of my trickier molecules. Who do I put in the center, the B's or the F's? Okay. What is weird about boron? It is an exception. It only wants how many electrons? It only wants 6. Can I do anything else to this boron? No, he's done. So where do I put the extra electrons? Around the fluorines. Do I need to do anything else to this molecule? Can I draw this in any other way? Are there any other ways to move those electrons around? No. No resonance structures.
Are there any other ones that only want like that one electron amount?
Beryllium, Be.
Okay.
So element 4 and 5, Be and boron.
How many is that?
They only want 6. Could have 4. But it's okay with 3. It's a weird thing. All right, is this molecule polar? It is not polar. Not polar, not polar. Have I drawn it in its correct three-dimensional shape? That's the issue. So what shape should this be in terms of Vesper? Trigonal planar, right? Ooh, that R got away from me. So in reality, it should look more like this. Right, so if we draw it like this, and we're like, oh, I see. That they evenly cancel each other out. So this was non-polar.
Can we draw our Lewis dot structure like that? Or?
You can draw it however it's correct. So sure, you can draw it like this. All right, questions about 1 or 2, A or B, whatever letters I'm using. All right, let's do NO3. Just a hint, obviously it's going to have a resonance form because I haven't given you any. Just saying. What does this big old -1 mean? Negative charge out to make sure I add an electron to my counting. So nitrogen brings 5 plus 3 oxygens, 3, 6, 23, 24 altogether. Yes. Okay. Yeah, someone should be double checking on my math today. All right, so how many have I used so far? How many electrons? 6. Can nitrogen have an expanded octet? No, it cannot. So how many can it have total? 8. So any structure you draw can only have 8. So what is a way to fix this? Sure. Come on, we'll put it there. So right, now nitrogen has its 8. And so how many did I say? 24, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 2, 4. Did that use up all the electrons?
Wait, no.
I can't. It did. Use them all up. Okay. So what would be a possible resonance structure for this? I can move the double bond over. That would be fine.
But you said it needs 26 electrons?
24. Yeah, 24. Is there any other resonance structures it could have? I could go the other way with it. Good. Yeah, so then we have to figure out, one, is it polar? Oh, question first.
Why is it that you can't put a lone pair on it? Like instead of doing like a double bond with one of the oxygens, you put like
Move those two over here, then the oxygen wouldn't have enough. Right, if I moved the 2 electrons from this lone pair over here, then it wouldn't have enough electrons.
Oh, okay.
The oxygen would be lacking. So, what molecular shape does this guy have? Keep thinking. Trigonal planar. Has no lone pairs. Double bond counts the same as a single bond.
This is for molecular?
It's still just trigonal planar. All right, because there's no lone pairs. There's only 3 things stuck to the nitrogen. Doesn't matter if it's a double bond, single bond, just means there's 3 things stuck to it. So even though these 2 guys look very, very different, they're the same 3-dimensional shape. So is it polar or nonpolar?
Wait, nonpolar.
It is nonpolar. It's weird because it's a charged thing,
You
but
don't need to add the charges to each one?
oh yeah, I mean I guess to be official we could do this. That would be fine. All right, let me do one about mole fractions, and then I'll open it up to whatever questions you may have left. Or maybe those are the only 2 things you want to cover. Let's see, mole fractions. I keep the binder because it makes me look organized, but I'm not particularly organized today. All right. All right, so a mixture of 3 gases has an overall pressure of 7.85 atmospheres. Oh, I messed it up. There we go. All right, we know that gas 1 has a mole fraction of 0.74. Gas 2 has a mole fraction of 0.21. I want to find what is the partial pressure of gas number 3. Okay, so we need to use our partial gas law equation, partial pressure gas equation.
Are you gonna give us these, or you have to know?
You have to know all the equations. I'll give you all the constants, and then I'll give you a periodic table. I'll throw that in for free.
Oh.
Yeah, yeah. I'll even have a spot till you put your name. I know. I know. I'm a very generous professor. No. Maybe. We'll see. Maybe I'll feel crazy. I may put a date on it. We'll see. I don't know. I don't know if I'm feeling that generous. No, you don't want any of that. The problem is, the more things I give you, the harder I have to make the test, right? So if you can bring in the equations, then I have to make the test harder. But if I know in my head, man, they have to memorize a lot of stuff, it means I'm going to dial down the challenge. Okay.
Just keep in mind, we have to memorize our name too.
Yeah, that is true. That is a lot. That's a lot of pressure. Maybe I'll pre-name them. That way I can just pass them out and be like, one thing off your mind. You don't have to remember who you are. I would bring a calculator. Forget who you are. Just bring a calculator and a writing utensil. Because in my senior class, they get an open book test, but they also have to take 48 hours to do it. Because it's a lot of work. It takes them no less than 48 hours to complete the test. So the more things I give you, the harder I have to make the test. Instrumental analysis. Unless you're a chemistry major, you probably won't take it. But if you are, you can always take it.
If you're a chemistry minor, do you take it?
No, you don't have to.
What is it?
It is. No, instrumental analysis. Where we build instruments.
I don't have to take that.
You don't have to. But again, why would you not want to take it with me?
Because I'm gonna teach little kids.
Okay, fair enough. Oh, okay. All right, so how do I go about solving this equation? Find the partial pressure x. That's x. So how do I find x?
Put the total mole fraction.
Okay, so a mole fraction means it's a fraction of what number? So what do fractions all add up together to be?
The total.
Like if I have 1/3, they all add up to 1, right? So that's the first step. You have to figure out what x is. And if you know that all of them add up to 1, since I made this question up off the top of my head, I actually have no idea. 0.74 minus, no. Someone should probably be double checking me on my math. It's not looking good. Oh, okay, good. That's what I got. All right, then what was the total pressure given? Yeah, that guy up there, okay. How many significant figures do I get to have in my final answer? That's 3. How many sig figs is this? 2. So how many do you get to have? 1 point. And what are the units? Atmospheres. All right, what other kind of questions can we work on? All of them. Probably less than all of them.
Most of them?
Most of them? I mean, are there any questions anyone has on the,
For number 14, I was solving it, and I got sulfur as another possible one, but I don't know if it was.
oh, see, this was on your quiz, it's a trick one. So, this involves your knowledge of how gases come. So if I'm looking at 14, you get to a molecular weight of 32. which sulfur by itself weighs 32 and oxygen diatomic weighs 32. Does sulfur exist as an S by itself? It does not. How does S normally come? S8. It normally comes as an 8-pack, which means this is not a good option. Oxygen is the correct, so it's doubly tricky. Because not only you had to figure out the molecular weight.
You have to know that.
Sure. So when you got to the answer for this one, since the video doesn't record this, I'll go ahead and write it. Question 14 on practice. You have density equals 1 point. Make sure I'm writing somewhere on the screen. There we go. It's like A2 BS CO2. D was some crazy option. Neon. Yeah. All right. So if you solve this, you would get to the molar mass is right around 32 grams per mole.
What happened?
That's a different question. You want me to do that first?
Yes.
Okay. All right. So if density is 1.43, all right, so this is one of the equations that we had at some point where we changed P equals nRT into density equals P times the molar mass divided by RT. Move some things around. All right, and the density is given. And we're looking for this M. The problem also tells you at STP, which I think mastering does a lot of stuff at STP.
Can you change, because the density that we have is grams per mole.
Oh, that's a typo. It should be grams per liter.
Okay.
Make sure that's right. Oh, that's why I see why it's a typo, because it says grams per mole. I meant milliliter, right? Density is in grams per milliliter. So change this to grams per milliliter.
So are we going to change that to liter?
In a minute. We'll get there. All right, so if it's at STP, what's the pressure of STP? 1 atmosphere. And R is the gas constant. Which I think I gave you someplace.
What's 273?
Oh, yeah, hold on. Liter atmospheres per mole. Okay. 2. Do I have the 2 and the 0 mixed up? 8? Yeah.
0.0821.
2. Okay, there we go. And temperature is 273 at STP. All right, so 1 divided by 0.0821 times 273. I'm clearly typing the wrong things.
I have 320.
320? This is probably not a good day for me doing the practice problems. Okay, let's see. 1 divided by 0.0821 times 273. Nah. It's not that at all, is it?
That's better.
Yeah, there we go. Okay.
Okay, yeah, no, I got that one. When I divided that to the other side, I got 300. If I had to do this by steps, how many decimal places should I go to?
I mean, it's a multiple choice question, so it doesn't really, yeah. So you get something like 32.05 or 32.1 or, right? 0.06. I'm not trusting my calculator right now. All right, so if you get to this, right, you're in, which is where we were over here, 32, 32. Okay.
Per milliliter?
Well, I didn't carry out all the units. It's going to end up in grams per mole. So if I have that, grams per mole, and those are my three options, what are the two that are good options? Right, this is a good option that's in terms of mass. Right, because those are the only two things that have that mass. And then this goes back to, right, sulfur comes as a group of 8. So sulfur is not a good option based on what we know about sulfur. So we talked about this a while back, right? All of the halogens come as 2s, and oxygen and nitrogen come as a 2. But then sulfur comes as an 8, and phosphorus comes as a 5 in their normal elemental state.
Why is chemistry gotta be complicated?
Because if it was easy, everybody would do it. So we make it challenging to scare off people who aren't real excited about it.
Wait, so do we need to know all these exceptions? If so, can you say them so I can write them down?
Yeah, the only exceptions you need to know is that sulfur comes as an 8. I think that's the only thing that'll show up.
Okay, what did you say phosphorus was?
5. Yeah, but that, I mean, fun fact, won't be on the test.
Wait, so like you're saying that if you like happened upon sulfur in nature, you would find 8 of them stuck together?
Mhm.
Okay.
Yep, yeah. Yes, just sulfur likes to be in 8 packs. 8's a chemistry number. It is, it's the buddy-buddy system. The buddy cube system. Right, 2 cubed, 8. That's my math joke for today. Math joke. All right, yeah.
I think it's a question of which ones do except for ATM, STP, not like,
No, just if you know STP stands for 1 atmosphere, standard temperature, and you know atmospheres. I'm not going to have you convert atmospheres to torrs to millimeters of mercury. It's not particularly useful.
So we're not gonna have to like, convert milliliters and liters and all that stuff to regular mole?
Oh, no, that's atmosphere pressures. I'm only going to ask about atmospheres. I'm not going to have you go atmospheres to torr to millimeters of mercury. My questions are all in atmospheres.
Are they all in straight grams?
I believe so. Yes, I can't think of any questions I have there not in grams. What other kind of questions? We have some more gas laws we could cover, or we could talk about.
Can you click on the track?
Oh yeah. Naming, polar, non-polar. What else we got? Octet rules, electron geometry.
Let us know about anything that's not on this, that's like general knowledge that we need to know. Like, do we need to know all the different, like, Boyle law, Avogadro's law?
If you know the ideal gas law, you technically already know all those other ones.
What about kinetic energy and all that?
Kinetic energy, yeah, that's on here because there's where was it? Maybe not. It was on your quiz. There's that picture of the graph with the different
So we
speeds,
need to know about
something like
kinetic
that.
energy and like all the true falses of it?
Yeah. Yep. I'm not going to ask you to solve for that. No. Yeah, in terms of kinetic nuclear theory, knowing that heavier stuff moves slower and light stuff moves faster, and temperature, hotter it is, faster it goes. Yeah. Yeah.
Balance
Certainly can. It is, but the one that's gonna be on there is gonna be like really easy. But we can certainly do some. Yeah, we can do one. Let's see what I can come up with. All right. Comparable to the test. All right. It'll probably be something balancing, looking like this.
Okay.
It'll be something along the challenge level of that. Yeah. No, I can do another one. Hold on. If I mess it up, you were writing down, okay?
Yeah, that makes sense.
All right, here you go. Here's the other one.
Yeah, two, two. Bang So hard.
That's gonna be it.
Okay.
Because there's so much other stuff that needs to be on the test that I can't have you struggling balancing the equation for the majority of the test. I need to do a bunch of other stuff. Yeah,
Will you do a naming with like?
I would love to do some naming. Yeah, yeah. I have some great naming questions. Yeah, transition metals, regular metals. Okay, on the test, guaranteed, there's going to be two types of questions. There's going to be a question that's of this sort. Name the following. And then we're going to do some other ones that are right at the formula. And I'll give you some names. So if I wanted you to name the following, let's see, how about we do that one, this one. Okay, we'll have those, and then for these down here. Oh, I forgot one up here. Hold on. There we go. Transition metal. All right, so guarantee there's going to be two sets of questions that fall into one of these two categories. So either I'll give you the structure and I'll ask you to write the English words, or I'll give you the English words and I'll ask you to write out the atomic formula for it. All right, so looking at these, first thing, looking at this, is this ionic or molecular? It is ionic, yes, right? So calcium is a metal, so automatically the answer is going to be ionic, because anything that involves a metal is ionic. So how do I name things that are ionic? Name the first word. There's too many I's in that. There we go. And then this guy all comes together. Carbonate. calcium carbonate.
You have to
For
know
the
the
chart?
charge for carbonate and know that there's like some chance on that, right?
Mm-hmm.
So then there's no Roman numerals.
There's no Roman numerals if it is not a transition metal. So only these guys in the middle here need to have Roman numerals.
4 and 3 and 4. Like aluminum.
I don't have aluminum on the test because it is technically a transition metal, but it's kind of confusing because it's underneath the stair steps.
Yeah.
So, but we're gonna stick to my favorites: iron, ruthenium, osmium. Man, osmium's a great metal because it acts like iron because it's in the same column, but it's not iron because iron's found in your blood. But osmium has all the same properties. So technically, you could probably swap out osmium for iron and do a whole bunch of awesome stuff with it.
But you'll give us the Roman numeral and we'll know the charge of the other one and figure out.
Yes.
that.
Yes.
Like the iron in our blood, is that different? Like, is it different types? Is it like the Roman numeral?
Yes. It transitions charge. Yeah.
Okay.
Yeah.
So, like, it depends on,
Was attached to. Yeah, iron's super neat in your blood. Changes charge. Different parts of your body have different kind. Side note, that's all fascinating biochemistry stuff, but we'll just practice naming for now. All right, what about BF3? Yep. And do your best at spelling. I'm not going to penalize for the spelling unless it's so far off that I don't know what you're writing. And also, don't try to trick me by writing it like try. I'll just assume that you're trying to trick me and mark it wrong. Like, you need to have some sort of legibility for me to give you credit. But the spelling won't count against you unless you spell fluoride like carbon. If you spell it so wrong that I'm not sure what you're writing, then I have to penalize you. All right. What about this guy? Dinycian. Mm-hmm. Pentoxide. Yeah, and I'll accept it with or without the A. Both are fine. Pentaoxide or pentoxide.
Could you also say dinitrous pentoxide?
Yeah, that would be fine too. Okay.
and that's in chemistry.
I know, it's much pickier than I would be, but that's why it's on the homework, not on the test. On the test, I have to be more generous. What about this guy, ionic or molecular? Ionic, so it's sodium.
Do you have to put Roman numeral?
Nope, because it's not a transition metal.
So you don't acknowledge the 2 at all?
Nope,
No. So then just that phosphate.
sodium phosphate.
So,
So there's 2 sodiums, but you would know that because phosphate's always -2, and sodium's not a transition metal. It's always, always, always +1. So you don't have to tell me the Roman numeral. All right, this one though, iron is now one of our transition metals. So you do have to tell me which iron it is. All right, so I'll get you started. Oh, I'll even do this. 2. How do you know it's 2? Carbonate's always -2, so iron has to be +2. You could call it ferric. The IUPAC naming just calls it iron. So, yeah.
Okay, and then for the next one we're writing down, do
Mhm.
you care if we start with, technically with the product would be?
No.
So it doesn't matter with the arrow, you still want to go
Yeah.
in the same direction every time?
Yeah.
Okay.
Yeah.
One question, why is the sodium phosphate and the boron trichloride, or I mean the calcium carbonate?
Mhm.
Why are they both in tape when I thought it was dealt with like the O3 and O4?
Oh, that's tricky. So CO3 is a combo ion, and its combo ion name is carbonate. Like if I wanted to call this properly, it would be the carbon trioxide ion, but its common name is carbonate. Yeah. Okay. All right, why don't we try lithium sulfate, ionic, molecular. Ionic. What's sulfate? Okay, what is the charge with sulfate? What's the charge with lithium?
I mean, plus.
So how do I have to combine these together?
And then do you want us to balance it or no?
No, that's what I want, that's all.
So it doesn't.
Yeah, it tells me, like, even though it's not in here, you know because of sulfate, you have to have 2 lithiums. So,
Plus in between each lithium.
you don't have to show me this step. If you can do this part in your head, then you don't have to show it to me. For me, I have to write it down to keep track of everything, so,
And we don't have to include the state.
no. Mm-mm. All right, so iron. Does anyone know what the perchlorate ion is? Cl. O4, what charge? -1. Yep. So how many irons then do I need? Just one. Is this guy ionic or molecular? Molecular. So N2 has 3. I have no idea. I don't think that's a real thing, but
Do we not know? Oh, you don't want us to write out the whole thing like that plus that equals this?
that's just in your head, or you can write down. Either way, I just want this is what I want is your final answer. You can show me your thought process.
Well, I thought when it said formula, like you wanted the actual.
Oh no, sorry, like the whatever that's called. Formula. What about this guy? P4. Oh. No, for sure doesn't exist. Yeah. All right, what else?
Number 8.
Number 8. Let's see what number 8 is. Mass percent. Sure. All right, so give the mass percent of carbon in this gigantic compound, C14H19 NO2. So, what's the first thing I have to do in order to be able to figure out mass percents? I know the entire molar mass. So what is that? It's 12 times 14 plus 1 times 19 plus 14 plus 2 times 16. It's okay if it's rounded. You can use the exact molar mass if you want, but. 233? Okay, that's what I got. All right. What's the next step I have to figure out? How much just carbon weighs in this thing, which is this part right up here. So just carbon is 12 times 14. 160. Do people still do the little dots for the symbol for math multiplying? Yeah. Okay. I've been in high school for a while, so I don't know. All right, what's step 3? That divided by that, right? All right, and I got time for like one more question. Anything else? Yeah.
Just this like general format? Is it multiple choice or is there?
So there's going to be, I think I ended up with 8 multiple choice. 8 of the ones we just did like this, so 4 of this style and 4 of this style. And then I think the rest of the questions are more like what we just did here, where it show your work in some kind of way. So,
How long those questions are like opening questions or finally just like rounded numbers as far as it goes? For like molar mass?
yeah. As long as you just make sure you tell me what molar mass you used, that's fine. 7 or 8 multiple choice, 8 naming, and then the rest are going to be 1 balancing. And the rest are going to be kind of open-ended questions like, given a pressure of 1 atmosphere, a volume of 30 liters, fine. Yeah, math.
How many naming?
8. 4 of this style and 4 of this style.